Hi there, this is Enigma channel and today we're gonna be analyzing one of the UFO videos released in 2017, recorded by the Navy and confirmed by the Department of Defense. By now most of you know the story of the encounters from the multiple interviews with Commander Fravor and other witnesses in shows like 60 Minutes and Joe Rogan's. The purpose of this video is not to give a definitive solution to the mystery due to the lack of information publicly available related to this event. However, using some math and common sense, we can arrive to some conclusions that can help to understand what these objects could be. Now let's watch the full video before diving into the details.
Nickel 6-1 Tango Logic, over.
Oh, got it! Woohoo!
Roger, there's troubleshooting as soon as I get
Did you box moving target?
602.
No, I took an auto track. Oh, okay. Oh my gosh, dude. Wow, look at it fly!
Okay, after seeing that video, let's see what those indications mean in the screen. Here we have range, that would be the distance between the fighter jet and the target. Also we have the jet altitude, the speed, and two more angles that we'll discuss in the next picture. Additionally, we take two assumptions. First, the measurements in the screen are correct, and second, in narrow view at zoom 1.0, the field of view is 1.5 degrees. Before continue, I would like to address the claim that the range in this case is a faulty measurement. Although it is possible, I don't consider to be likely, since this measurement, from my understanding, is taken from a radar or some active independent sensor, so in this case it's going to be considered as a good measurement. In this graphic we can see the relation between the jet and the target and all the angles we saw in the previous presentation. In the triangle below you can see the projection of the range in the jet plane in space, so we can better follow the trajectory of the target. In the following table you can see how I divided the video in frames of 1 second with all the measurements from the screen. The jet speed in the table is already converted to true airspeed instead of calibrated speed shown in the video. Also, you can see that the target altitude is pretty much constant, about 13,000 feet. We calculate the projections from the angles and the range, and we also calculate the jet trajectory for each second. In the first example we have the jet in a straight line trajectory, where we can see the target moving to the right. However, we can see from the screen the jet is making a left turn, indicating that it's not in a straight line. In the second example we estimated a turn angle, and you can see how all the points start crossing in the same area. Since we don't have a good measurement of the turning angle, we decided to use only the first 5 seconds of the table, that we know the jet stays in a stable straight line. For the first 5 seconds we can see the target doesn't move very far. You can notice an irregularity in the position of the target between points 1 and 2, and that distance is about 135 feet, and this is due to the resolution of the measurement. In this case is 0.1 nautical miles, or about 600 feet. The resolution error of 600 feet is greater than the 135 feet between the points 1 and 2. Therefore, we can estimate a trajectory in the middle of those points. The estimated distance is 343 feet in 5 seconds, which is 46.8 miles per hour. Knowing the distance to the target and the field of view, we can estimate the dimensions of the target from the picture. First, we measure the horizontal dimension of the screen. Then we measure the dimension of the target. Notice the shape of the target is rounded, but we are only measuring the horizontal dimension. In this table, we calculate the size of the object using 3 different field of view and 3 different distance for the same frame in the video. We can calculate then 9 different sizes. The object should be between 5.7 and 12 feet, being the more likely 8.7 feet. Now let's try to identify this object. Could it be an airplane? The size, speed, and shape is not consistent with an airplane. Maybe a bird? Maybe, but the size and shape still not consistent with a bird. I couldn't find any atmospheric phenomenon consistent with the characteristic of this object. It could very well be some type of drone, however the speed is very slow for that altitude. Additionally, there is no sign of propulsion. In my opinion, the balloon option is the more simple and compelling of all of them. That's why we are going to explore this option further. And finally, for considering the extraterrestrial option, we'll need to see evidence of more advanced capability that are not shown in this video. I was able to find this weather balloon with similar characteristics to the object in question. In this chart, we can see that in the case of it being a weather balloon carried by the wind at the altitude of 4,000 meters or 13,000 feet, the wind could very well have a speed of 20 meters per second. In this final comparison, we can see the objects are almost identical. Does this mean that the object is a weather balloon? Well, no. In this case, we can only make an estimation with the information in hand. It could be possible that the air direction and speed were different and our estimation is incorrect. We can arrive to the conclusion that the object does not present any advanced capability, not defy any of the known laws based on the instrument readings. But we can say with some confidence that the object presents similar behavior to a low altitude weather balloon at wind speed. Thank you for watching and wait for my next video on the Nimitz event.